Okay, so solving differential equations, tangent line equation, linear approximation, creating slope field, multiple choice, word problem involving CE to the KT, completing the square, and then the 5.2, 5.5 quiz topics. Any particular one you want to start with?
Could we do the slope field?
Okay, so this is on page 11 of the packet. We can just kind of go through a bunch of them here. So page 11, this is from the 6.3 packet. So if you go to that 6.3 packet here, okay, let's see. So I think we did numbers 1 and 2 in class, right?
Yeah.
Okay, let's go to page 12. Let's look at number 4 here, page 12. Okay. It's tough to see these options here, so I'll write them again. Okay, so the things that we like to look for are, where do we see a collection of slope undefined? Where do you see a collection of slope 0? Positive slope and negative slope. Okay. Do you see any place where slope is undefined?
Is it 1?
Okay. X equals 1 or Y equals 1?
Y equals 1.
Yeah, everywhere that Y equals 1, I should be getting undefined slope. So are there any of these that we can eliminate?
I'm not completely sure.
Okay, so let's try the first one here. If I plug 1 in for Y, am I getting undefined slope? Because these are all dy dx's, right? What happens if I enter 1 in for Y?
It's 0 squared.
Mm-hmm.
So it's 0.
Okay. What happens when you have 0 in the denominator?
It's undefined.
It's undefined. So that's consistent, right?
All right.
So that's good. Okay. How about the second one here?
That one is not undefined.
It's not undefined. So this doesn't match with the graph we see in front of us.
Mm-hmm.
So this can't be the right answer. Okay, eliminate this one. Now these other ones, they all have y minus 1, so we have to still keep this in play, right? Okay, do you see any slope zeros?
I don't know.
I think I see, I don't know, sometimes it's hard to tell, but I think there are slope zeros here. Right, those are all slope zeros. Now sometimes it's could be the tick marks on the y-axis, but I do believe that these are slope 0. So slope is equal to 0 when x is equal to 0. So when x equals 0, we should be getting dy dx equals 0. So I think those are still in play, right? 0, 0, 0. So I don't think we made any progress there. Okay. All right. Where do you see positive slopes?
Quadrant 2 and 4.
Mm-hmm. So that means if I enter any order pair in the second quadrant, I should be getting a positive number. And if I enter anything in the fourth quadrant, I should be getting a positive number. Okay. Where do you see negative slope?
In the first and third one.
Okay, so let's test out quadrant 2, right? Quadrant 2, an easy order pair would be what, negative 1, 1? Or sorry, we don't want to use that, right? Let's do negative 1, 2. So that means if I plug in negative 1, 2 into the correct differential equation, I should get a positive in return, right? So let's see if we get anything that we can eliminate. So if I plug negative 1 here, denominator squared, so this is giving me positive. Okay, so that's good. This one, I'm getting positive over positive. That's good. All right, here, what happens if I plug in for D here? Am I getting, yeah, I'm getting positive as well. Okay. Negative. Okay, so it looks like we're still in play. Okay, quadrant 4, let's try 1, negative 1. So 1, that's negative. I don't think this is I don't think this is consistent, right? If I plug 1 in for x, I'm getting a negative 1, and negative 1 is not, we don't see anything in negative slope here. So I think we can eliminate this one here. All right, does that make sense?
Yeah.
All right. All right, if I plug 1 in here, I'm getting negative over a negative, which is positive. Okay, I keep it. Here I'm getting positive over a negative. Positive over a negative. Okay, I can eliminate this one as well. This is not correct either. So I think we're down to C. But let's just go ahead and test some more, right? Just make sure, just get extra confirmation. If I plug in 1, 3, or anything in the first quadrant, I should be getting a negative slope. So if I plug in 1, 3 here, I get negative over a positive. That's negative. That works. Quadrant 3, let's try negative 1, negative 1. I get a positive over a negative. That's negative. Okay. So I think if you just go down your list of options, you can begin to kind of start eliminating the ones that are not consistent with what we know to be true based off of what we observe. Okay, does that make sense?
Yeah, it makes sense.
Okay, all right, let's continue on number 5. Okay, so, let me write these out a little bit more clear here. Okay, so do you see any place where the slope is undefined?
X equals -3.
Okay. All right, do you see any place where the slope is 0?
Is it the first quadrant?
Yeah, you know what? These are all slightly, yeah, I know that they kind of look like slope zeros here, but there's one particular place where we can say definitely a slope 0. Do you see it?
Is it x equals 6?
X equals 6.
I'm not
quite.
sure.
Yeah, I think it's going to be here.
Oh, okay, I see.
You see how these are slightly positive and these are slightly negative? I know it's tough to see.
Yeah, okay.
I think we can kind of see that this is straight across all the way. So this is when y equals 3 for the most part. Okay, can you make a general observation as to when we're experiencing positive slope on this graph?
I'm not completely sure.
How about negative slope? Do you see a dividing line that kind of separates the positive from the negative slope?
Oh, is it y equals 3?
What happens above y equals 3?
Positive?
Yeah, see how these are all positive slopes here?
Okay.
Then everything here, we're seeing some negative slopes. So positive slope, whenever y is greater than 3, it doesn't matter what the x value is, right? As long as the y is greater than 3, I'm getting all positive slope. But as long as the y is less than 3, I'm getting negative slopes. So if we're getting all this detailed information, we should be able to eliminate the wrong choices and make our way down to just 1 or 2, right? So which one can we eliminate? It says slope must be undefined at x equals -3.
we can eliminate D and B.
So if I plug -3 in for X, am I getting undefined slope?
Yes.
We are, right? So we have to keep it because,
Oh, okay.
right, we want to keep the ones that make this true. We want to remove the ones that make these statements false.
Okay. So keep B and D and I'm not sure.
What if I plug -3 into the first one? What would I get if I plug -3 into the first one?
So that would be 0 times y minus 3.
Which is equal to?
0.
Is 0 the same thing as undefined?
No.
So if I'm not getting slope undefined at -3, then this can't be true for this graph.
So we can eliminate.
Right, we can eliminate. Is there another one that we can remove?
C.
Yeah, if I plug -3 in for X, I'm getting 0. And 0 over y minus 3 is not necessarily going to always be undefined. Okay, second one, slope equals 0. So we're just down to B and D here. Can we eliminate any with the second statement? Okay. What happens if I plug 3 into the second one?
You would get 0 over x plus
0
3.
over x plus 3 squared is still 0, right? So that's still true. So we can't eliminate that one because that's a true statement. How about the last one?
That would also be.
Yeah, also be true. Yeah, so looks like the second statement didn't help us remove anything. Okay. Now, positive slope. So that means if I choose any y value greater than 3, so let's test y equals 4. If I plug 4 into the differential equation, no matter what, I must get a positive number. So is that going to be true with the second statement?
Yes.
Yeah, this is both are squares, so I'm getting positive no matter what. Okay, how about this one?
Also yes.
Also yes. Okay, so it looks like we couldn't make any, yeah, we couldn't eliminate any with the third statement. Okay, how about the last statement here? Negative slope when y is less than 3. So let me test y equals 1. Okay, you could have tested 2, you could have tested 0, you could have tested -1. I'm just choosing the arbitrary number here. Okay. Am I getting a negative number when I plug 1 into this one?
No.
I'm getting positive, right? You see how the numerator and denominator are both squared? So no matter what, this differential equation is always getting me a positive number. But I don't see a positive number here, right? I don't see positive slopes here. So I think we can eliminate this one, right? Okay, let's double check. If I plug 1, 1 minus 3 is negative, negative or positive. So yes, looks like that y is greater than less than 3 is dependent completely on the numerator. The denominator is always positive. It's that numerator, right? Like 4, 5, 6, 7, that's all going to be a safe positive number. But as soon as it dips down to a 2 or 1 or 0, negative 1, it's going to turn into a negative. And we see all those negative slopes showing up here. Okay, does that make sense?
Yeah, that makes sense.
Okay, let's try number 6. Okay, do you see any slope slope undefined?
No.
Yeah, it's tough to tell, right? Maybe it's on the x-axis, but maybe that's slope 0. So you're right, we don't know. Okay, maybe there is, but we can't really tell. Do you see any slope zeros?
X equals 0.
Yeah, looks like that could be it. Just have to be aware that sometimes that could be slope 0, but sometimes those are tick marks as well. So we'll say maybe x equals 0. Yeah, so sometimes we just have to be aware that it's almost kind of purposely making it vague so that we're forced to look elsewhere. All right, do you see a collection of positive slopes?
Quadrant 1 and 3.
Mm-hmm. And then negative slopes?
Is 2 and 4.
Now, there are 2 other things that we could look for because it's tough to tell slope of 2 or slope of 5 or slope of 6, but sometimes it's easy to tell slope of 1. Do you know what I mean? Do you see a collection of slope 1s on this graph? Slope 1 is basically a slope that looks that's exactly like 45 degrees. You see that here?
Yeah, I see it.
See how those are perfectly diagonal? So that means that 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2. So all those are creating, right? So that's something that we can look at, right? And then do you see any slope negative ones? Along the other diagonal, right? You see that?
Yeah.
So that's when x and y are different signs, right? Negative 2, 2, 2, negative 2. Okay, so we really can't do anything with slope undefined, and slope 0 is really not helpful because there's not a easy thing for us to tell. But we do know that we're getting positive slopes in the first and third quadrant. So, so that means if I tested 1, 1, or if I tested negative 1, negative 1, I should be getting a positive slope, right, in those quadrants. Okay, so is there any that I can eliminate here?
I'm not sure.
Okay, let's test them out here. If I do 1, 1 into A, is that positive?
Yeah.
Okay, how about -1, -1?
Positive.
Okay, so we keep going. B?
Positive.
Uh-huh.
And positive.
Okay, so we keep going, right? Those pass the test.
Mm.
How about C?
Negative.
Okay, what can we do here?
Eliminate.
Yeah, eliminate, right? We know that 1, 1 should be giving me positive slope, but it's not giving me positive slope here, so I can take that out. How about D?
Also negative.
Yeah, that's out. Okay, quadrant 2 and 4. -1, 1, and 1, -1. I should be getting negative slopes here, but I don't think we can eliminate, right? Negative over positive, positive over negative, negative times positive, positive times negative. So these are both negatives. We can't do anything here. So we really want to kind of focus on these diagonals here, right? 1, 1, 2, 2, 3, 3, 4, 4. I should be all getting slopes of 1. So am I getting slopes of 1 if I do 1, 1, 2, 2, 3, 3, 4, 4?
Yeah.
Okay. So this should be a good candidate, right? Let's double check and see. How about this one? What slopes are we getting if we do 1, 1, 2, 2, 3, 3, 4, 4? Is it the same number every time?
No.
1. This one should give us 4, 9, 16. So all these slopes should be getting a lot steeper, but they're not, right? They're just holding steady at a slope 1. So we know that this is not quite true. It's going to be A. Okay, how do you feel? A little better or still a little strange?
I understand better. It's just like figuring out like the pairs to test in the questions is a bit.
Yeah.
But I think I got it down.
Okay, let's do 2 more here. I just figured that we'll just do all slope fields today for anyone who wants to watch the video, and then tomorrow we can maybe do like other topics like maybe synthetic division or other integral problems. Okay. All right, slope undefined. Do you see any place where the slope is undefined?
Y equals -1.
Mm-hmm. All right. Do you see any slope zeros? Maybe, right? Maybe x equals 0, but we don't know if there's tick marks or whether they are from the slope field. Okay, do you see a collection of positive slopes?
Quadrant 2 and 3.
Negative slope.
1 and 4.
All right, so let's test some order pairs here. Well, let's do slope undefined, right? Hopefully we can eliminate some wrong ones here. Slope undefined, y equals -1. Is there any that we can remove because we're not getting undefined slope at -1 when y is -1?
We can eliminate B.
B, you say B?
Yeah.
Yep, if I put -1 in for y, I get 0. 0 over x is not guaranteed to be undefined, so you're right. We can eliminate this one. This is not consistent with what we observe, right? All of -1 is undefined. Anything else?
Would C be eliminated?
Yeah, why would C be eliminated?
If we do -1 + 1 squared, that's 0, so A equals 0.
0 is not the same thing as undefined, right? So basically, you're only, you're right. So you're only getting undefined slope if there's something in the denominator, right? We see nothing in the denominator here, so there's no chance this can ever give us anything undefined. So this is not consistent with what we see in front of us. So if this is gone, then this is also gone. So that's nice. We just went, the first property we named, we can just get all the way down to the right answer. Okay, last one here.
Going back to that one. So if there's no, if the denominator doesn't equal 0, we can automatically eliminate it?
Because is there anything that can make this derivative undefined?
No.
Right, there's nothing that can make these two undefined, but we clearly see an undefined at -1. So we know that there's no way that these graphs can produce this.
Okay, I got it.
That makes sense. So the only -1 that I'm getting, the only way I'm getting undefined slope is when y is -1. So if I put -1 in for y, I'm getting 0 in the denominator, and that's undefined, right? And that's consistent with what we see here. Okay. All right, so do you see any undefined slope?
Could it be x equals 0, or would that go for slope?
You mean y equals 0?
Yeah, sorry, y equals 0.
Yeah, maybe, right? But we don't know if it's being covered up. Maybe y equals 0. But it's purposely vague, so we may want to depend on something else. Okay, how about slope zeros?
X equals 1.
X equals 1. All right, do you see a collection of positive slopes?
Quadrant 1 and 2.
Mm-hmm. Mm-hmm. Yeah, quadrant 1 and 2. Okay, how about negative slope?
3 and 4.
Okay, I think that's probably right for the most part. Okay. All right, undefined, let's skip this one. We really don't have any conclusive evidence there. Okay, when x equals 1, we should be getting slope 0. When x is 1, we should be getting slope 0. Is there any that we can remove?
B?
Yeah, what happens if I put 1 in for x?
Y over 0.
Which is?
Undefined.
Right, that's not consistent with slope 0, right? So those are not in agreement. If something doesn't agree, we can remove it. Okay. Anything else?
D?
Yeah, if I plug 1 in for x, I'm getting 0 in the denominator. That is not in agreement either. Okay, that's good. One property, and we can eliminate 2 choices already. Okay, so slope 0 at x equals 1. A and C are still in play. All right, let's test these out here. Quadrant 1 and quadrant 2, I should be always getting positive slopes. So quadrant 1, let's test out 2, 2. Quadrant 2, let's test out negative 1, 1. Okay, if I plug 2, 2, am I getting positive slope here?
Yeah.
Okay, if I plug negative 1, 1, am I getting positive slope here?
Yeah.
Okay, so that passes the test. Okay, how about C here? 2, 2, am I getting positive slope?
Yeah.
Negative 1, 1, am I getting positive slope?
Yes.
Try again.
No.
Negative 2 over 1, that's negative. Negative 1, 1 is in the second quadrant. It should be giving me a positive slope, but I'm getting negative in return. So this must be removed. So I'm down to 1. Okay. All right, hope that helped.
It did. One last thing, could you like show me through the packet like which topics the test is through?
Mm-hmm. So if you go to page 9, let's look at worksheet 4. So differential equation, slope field, create differential equation, specific and particular equation. Do you have this packet in front of you?
Yes.
Okay. And then find the equation with tangent line. All right, we did that today in class.
What was the first part? Sorry.
Solving differential equation. Or slope field, part A, right? And then part B, find the particular solution. So you got to cross multiply, go through all those steps, right? Okay. Solving equation or finding tangent line equation, and then doing a linear approximation.
Okay.
This is use substitution problem involving exponential functions. So word problem, y equals c e to the kt. Solve for c, solve for k. Matching, like how we just did now. Use substitution involving trig integrals. Arc trig. Arc trig involving completing the square. Synthetic division. Use substitution. Yeah, so those are the major big ones.
Okay, thank you.
Yeah, and then I have that full list on my website under today's date. Oh, sorry, under under test topics, right? So kind of highlighted all those topics there.
All right.
Okay.
Thank you so much.
Yeah, I'll see you tomorrow.
See
Bye.
ya.
Bye.